Hello everyone. Welcome to the free session of this IIT Jam and CSIR Net and Gate live lecture series. So I am Aryan Mehra. Okay. So founder of Physics by Aryan. So under this initiative, I'm taking daily class at 7 p.m. to explain the tough topics, which students usually find it hard to understand by themselves. So I'm using my expertise of the books which I have read, the interviews which I faced. I have faced almost 25 interviews at different places. So based on all the knowledge I gained, I am giving you the lectures which will definitely help you directly in both exams and interviews. So in last two lectures, we developed the basic foundation of quantum mechanics. That how we deal with quantum mechanics. Then we did all of that by taking an example of infinite potential well. So we developed some rules of quantum mechanics. We understood that what is wave function, okay, how to find the wave function and what does wave function represent for any particular system. And then we find solved the problem of infinite potential well in one dimension. Okay. So now we will move one step forward and I said in the first class that if you sort of find the energy eigenstates of any system, if you do not know what is energy eigenstates, I would suggest you to watch last two lectures. It's very important. If you have the energy eigenstates for any system, okay, I stated that you can find any other physical quantity of that system. So for example, it is an infinite potential well, okay, there is a particle inside it. Okay, it can be not a particle but a quantum entity. We can't describe now as a particle. So quantum entity is inside and we want to know what is its average position. So when we do the measurement of the position, where we will find it? We can find it anywhere, like here, but we will find at some one spot only. But we want to know that if the particle is in some state, whatever state it is in, and if we do the measurement, what is an average value of position that we will get? Average means if you take the measurements 50 times, what is an average value of that? Where is the mean of that value? Similarly, if we take to do the momentum measurement, what is the average value of momentum that we could get if we take the measurement of the momentum on this system? So this is what we will learn today, and this comes in exams. Direct questions comes in exams. So whenever state is given to you, state I mean energy eigenstate is given to you, then and they ask you to find the average of any physical quantity. It could be position, it could be momentum, and so on. So what you do is you use this definition that average value of A is here a physical quantity, any general physical quantity. The average value of A is this quantity. Now, how to understand this? This is actually, I told you yesterday that what is this? This is inner product. So how you find that? You find integral. You take the complex conjugate of the left hand thing and then write the means right hand thing as such and integrate it over the entire space or entire length. Okay, so similarly here what you do is you take the complex conjugate of left hand thing. Now if you want to find the average of A, you need to write the operator of that quantity. I told you that for any physical quantity there is one operator. For example, the operator for energy is Hamiltonian. Operator of position is as such position itself. The operator of potential is potential itself. The operator of kinetic energy is minus h cut square by d square by dx square, and so on. We studied that, but every physical quantity has some operator. So write the operator for that quantity and now just multiply it with, not multiply, since it is an operator, operate it on this state phi and dx. So you just need to find this integral. Okay, so if you find that integral, you will actually find the average value of the physical quantity you are studying. So let's understand with this an example so that it is more clear. So consider an infinite potential well. You know phi 1 phi 2, phi 3 are the energy eigenstates. And what are these energy eigenstates? We calculated. Phi nx is under root 2 by a sine n pi x by a. So your state, actually your system is in the superposition state of first energy eigenstate, second energy eigenstate, and third energy eigenstate. So it is actually in the superposition of these three states. The question now comes is how to find, if the system is in this state, what is an average value of energy in this system? Then we will talk about what is an average value of position of a particle if it is in this state. Okay, so average value of energy. So if I want to find the average value of energy, what I need to do, phi, instead of energy I need to write the operator and then phi. So for energy, we do not need to find the integrals. We do not need to do the complex calculations. How? So I can explain you that very easily. So first, let's divide it. So write this phi as like this and h phi as this. So divide it in two parts. Now I told you that what is h phi? H phi. It is equals to E phi. So can anyone tell me what is this equation called? What is this equation? Yes. So this is the first equation which we did, which we used to find the energy eigenstates as such. So let's now apply this. H to the phi. What is phi? Phi is 1 by root 4 phi 1, 2 by root 4 phi 2 plus 1 by root 4 phi 3. We are applying our h cut to this. So now I want the answer of these three questions. What is this value going to give you? Just try to see this. Here in place of phi, I have put phi 1. So what is the value of energy I will get? E1. Okay. It is in the energy eigenstate phi 1. Energy eigenstate. If I put phi inside of this, so you will get energy value E1, and at the phi you will get again phi 1. So similarly, if I do h cut phi 2, what you will get E2 phi 2. Similarly, h cut phi 3, you will get E3 phi 3. Very, very simple. Okay. So now let's come back to our energy. So what is then h cut phi? Complete h cut phi. So simply you can see it is E phi 1 root 2 by 4 E2 phi 2 1 by root 4 E3 phi 3. So can you see this? I have just this h instead, but operated on all three and I got this thing. So how many of you understood how I got this h cut? Do you understood? Yes, no?
Yes.
Or should I repeat? Yes. Everyone understood? Yes, no? Okay. So now moving forward. Yeah. So moving forward, average value of energy is phi and h cut phi. Okay, perfect. This I just defined it. So how we do this? So what is phi? So it will be just simply phi star into h cut phi. Phi star into h cut phi integration. So we can put an integration, or for a moment just ignore the integration. Means integration is there, but we are just not writing it. Okay. So what is phi star? Means, but our state was this. So what is phi star? Simply nothing fancy, but 1 by root 4 phi 1 star, 2 by root 4 phi 2 star, 1 by root 4 phi 3 star. And what is our h cut phi? H cut phi is written here. So it is 1 by root 4 E1 phi 1, 2 by root 4 E2 phi 2 plus 1 by root 4 E3 phi 3. So now the only information you need, or only information you need to recap is, tell me what is phi 1 star into phi 1. There is integral also. I'm just avoiding it. Integration is also there. So this is also there. So 1. So what is phi star into phi 2?
0.
0.
Only there will be 3 terms here, 3 terms here, so total 9 terms. Out of these 9 terms, how many of will be non-zero? Only 3. When 5 1 star will multiply with 5 1, when 5 2 star will multiply with 5 2, when 5 3 star will multiply with 5 3. Only these 3 terms will be 1. Other than that, all will be 0. So what is the value of answer we will get? So let's multiply this and this, first term and first term. Then I
One
will get 1 4 E1.
plus
Yeah.
2 by
So
4.
2 by 4
1 by
E2.
1.
Yeah. Perfect. So what is an average value of energy that you got? This is an average value of energy you got. Okay. So what does it actually represents? What does it actually represent? So let's dig in. Yesterday I told you, let's come up to this. If I do the measurement of energy on this state, what are the 3 possible values of energy I can get? Tell me. If I do the energy measurement on this state, what are the 3 possible values of energy I can get?
E1, E2, E3.
Yes, either I will get E1, or I will get E2, or I will get E3. I cannot get all 3. Sometimes I will get E1, sometimes I will get E2, sometimes I will get E3. Now tell me, what is the probability of getting E1? Probability of getting E1. I yesterday told you that whatever is a coefficient of your state phi 1, just square it. So probability of getting
1 by 4.
Yes. So probability of getting E2 is 2 by 4. Probability of getting E3 is okay. So let's write it. Probability of getting E1 is 1 by 4. Probability of getting E2 is 2 by 4. Probability of getting E3 is 1 by 4. So sometimes I'm getting E1, sometimes I'm getting E2, sometimes I'm getting E3. So what is an average value of E? If you know basic statistical mechanics or basic probabilities, you know if you need to find the average value of E, then you what you do is, how many of you know this definition? It is not something I am making up. This is a statistical mechanics. So what is an average value? So the value what we are getting and what is the probability of getting that value, and then you just sum it, you will get the average value. Do you all understood by the class 11 12th concept? Can you see this? Tell me, can you see this definition? What is the average value of anything? Whatever is a value and whatever is a probability of getting that value, and just sum it. So don't you think it is this that only? The value E1 and probability of getting E1, value E2 and probability of getting E2, value E3 and probability of getting E3. So do you understand that these two definitions, they are actually different definitions? One is statistical mechanics definition and second is the thing which I defined now. So how many of you understood this very clearly? Tell me very quickly. Difficult concepts that I am going slow. Can you hear me all?
Yes, sir.
Yes, sir.
So do you understood this concept or not? I will repeat if you are not understood. Okay, so let's move on. So we have found the average value of energy. So now let's find the average value of position. We define that again, the phi into x into phi. X is x operator. So x operator is x only. We should remember that x operator is x only. So we just need to write x here. So now we need to do an integral. We need to solve an integral. Why now here we need integral? Because in the previous case I said when you put h cut in here and then you apply it phi, then I know the answer was E phi because this is Schrödinger equation. Now I put x phi. I do not know what is the answer because there is no such equation here. because I had the energy eigenstates. That is why I can use this. But since I do not have the position eigenstates or momentum eigenstates, I have to do the integrals. So what is that integral means? Phi star into x into phi. Phi star into x into phi. So to make the question little bit easier. So let's assume the phi is now simply phi. Phi is not what we did in last question, but phi is now simply phi 1. It means your system is in ground state. It is in the ground state. So can animal tell me what is phi 1? What will be the phi? In for infinite potential well, what is phi 1? Root 2 by a. What else? Tell me very quick. It's a simple thing.
Sin K.
And pi x by
Sine pi x by a. Perfect.
again.
Yeah. So let's do it. What is phi star? Phi star is also root 2 by a. If I do the complex conjugate of sine, it is sine itself. Okay, then x, then root 2 by a, sine pi x by a dx. So limits are from 0 to a. Inside well only. Outside well, the wave functions are 0, so that is why we are not considering. So it within that only. So 2 by a, x sine square pi x by a, 0 to a. So can anyone tell me what is the value of this we will get? So it's a very simple. X 1 minus cos 2 pi x by a by 2 dx 0 to a 2 by a. Okay. So let's take this 2 outside. So 1 by a. So x minus x cos 2 pi x by a dx 0 to a. So root 2 by a. So you will get the answer a square by 2 a by 2. So if you solve it, you will get this answer. You can easily solve this integral and you will get the answer a by 2. So now let's try to see. Yeah. Yes. Any questions? Or should we also do this also calculation? I think you will get a by 2, but try to see also this. I think maybe this can also be non-zero. So let's do it. I think we should not skip the part. Maybe that I made it the things wrong. So x square by 2, 0 to a. Now how to find this integral? By integration by parts. So keep first thing constant and integrate second 2 by x by a 0 to a divided by 2 pi by a, then minus minus become plus, then it becomes again minus sine 2 pi x by a 2 pi by a whole square 0 to a. Okay, so 1 by a, this becomes a square by 4. If I put value here, it is 0. If I put value here, it is also 0. So yes, answer is a by, sorry, a by a square by 2, a square by a by 2. So the average value of position in the ground state is a by 2, a by 2. How many of you understood this? Means not a calculation, but concept, how to find it. Integrals you have to find it. So if I give you the first excited state, let's say your phi is phi 2. Phi is phi 2. So then you just need to x by a and do the calculation. Simply do the calculation. If you do the calculation, what calculation? Position x is 2 by a 0 to a sine square 2 pi x by a into x into dx. So whatever value you get, you will get an answer. So now the physical meaning, I do not only can teach you the calculations. I want you to think of the physics. So this was a ground state. This was a ground state. Okay, this was a ground state wave function. So where the probability was maximum, a by 2. To find the particle at a by 2, the maximum probability was at the center. Okay. And when we do the average, so the most probable position and the average position are same in case of ground state. Do you understand this concept? The most probable position, because most probable position is a by 2, and the average means average position where you will find the particle is also a by 2. So this is something that you should imagine, that average position and the most probable position in the ground state is same. In the first and second exercise, this do not need to be true. Okay, so till here, how many of you got it clear? Then we will move to next, momentum, how to find momentum.
जो ऊपर कैलकुलेशन किए हैं
Yes,
हाँ वहां पे
yes.
जाना है
So simply x integration is x
वहाँ पे
square by 2
साइन
that you
नहीं इंटीग्रेशन बाय पार्ट्स में वो सेकंड है ना टर्म साइन की वो कॉस
oh
नहीं आनी
cos. Oh, you're right. So does this change the answer? 2 pi minus, no, does not change the answer. It is still 0, no? Okay, means cos 2 pi minus cos 0 is 0. 0 minus 0. Oh, sorry, 1 minus 0. So answer is still a by 2. But yes, here it is cos. Right. Sorry for that. Okay, so now let's move to momentum. So average value of momentum. So again, assume that your phi is phi 1. So let's do an average value of momentum. What is a momentum operator? Minus your attach cut d by dx. This I also told you in previous classes. So now if I need average momentum, I need to do this. So phi star, at the place of p, you need to put the operator of p, d phi by dx. Dx, take an integral from 0 to a. Phi star you know is root 2 by a sine pi x by a minus your attach cut d phi by dx, if you do, will be root 2 by a pi by a cos pi x by a dx. So answer which you should get is minus your attach cut 2 by a sine pi x by a into cos pi x by a into dx 0 to a. So let's take this 2 inside. So what you will get, minus your attach cut by a sine 2 pi x by a dx 0 to a. So let's do its derivation. Oh, sorry, the integration 2 pi x by a by 2 pi by a minus sine. So minus minus will get cancelled and it will become positive 0 to a. So answer is 0. If you put upper limit and lower limit, similarly you will get 0. So average momentum in the ground state is 0. So does your brain actually helps you in thinking that average momentum must be 0? I don't think so. Let me give you a very simple logic that without calculation you should know that average momentum should be 0. So let's say there is a particle inside this way. You know particle can't go outside. Outside there is an infinite potential. What is an average momentum means? Average momentum means inside this particle sometimes have speed like this, sometimes like speed like this, sometimes like this, sometimes like this, sometimes in the state phi 1 only. So it is in state phi 1, it has energy E1, and it is moving inside like this. Maybe just imagine it like a particle. You can't imagine it, means you can't say it's a particle, but imagine it like a particle. So it is sometimes moving like this, sometimes like this, sometimes like this. So the average is 0. So it is not going anywhere. Average is 0. So it needs to be true. Average must be 0. Why? Let's say it has some average momentum. It means it is going in one direction with some average speed. It is definitely moving like this, but there is some average in one direction. So there is some, if there is some average in one direction, means it has some average means you have calculated the entire motion and took the average of it. If it has average momentum in one direction, there will be one point when it will cross this barrier, na? This wall, which cannot happen. Okay, so that is the reason it cannot have average momentum. So that is the reason P momentum is 0 for all states. If your state is phi 1 or your state is phi 2 or your state is phi 3, whatever is your state, your average momentum needs to be 0 for infinite potential. Otherwise, your particle will, there will be some time in the, there will be some time when your particle will come out of this box. Otherwise, there is no possibility that your momentum would be, average value of momentum would be nonsense. So how many of you understood? It's a very important concept asked to me in the interview. So you should be clear with that. बताओ भाई, जल्दी जल्दी बताओ, टाइम वेस्ट मत करो।
ये अच्छे से नहीं आया वाला
समझ नहीं आया ये? Okay, so let's say, think like that. There is a wall, your particle is moving. Okay, your particle is moving like this. Okay, and it strikes the wall, it come back. Again it move like this, and again strikes the wall and come back. Okay, so half of the time its velocity is in this direction, half of the time its velocity is in this direction. So if there are walls which your particle cannot cross or break, then your average momentum must be 0, because half of the times it will be moving in this direction, half of the times it will be moving in this direction. So the average momentum would be 0. So if your particle has an average momentum, it is, if it is not 0, it means the walls are not working. Then it means your particle is going somewhere in the one direction. Okay, if there are the walls, they make sure that it collides back, and half of the time it is moving like this and half of the time it is moving like this. Okay, because if there is an average momentum in one direction, if you will see that motion for long time, then what you will see is the particle is moving in one direction with that average momentum. It will keep moving, so that cannot happen. Your particle has to stay within the walls. That is the reason your average momentum must be. So how many of you understood this? Also the calculations, your calculations can be
काइनेटिक इनर्शी से अगर
kinetic energy.
काइनेटिक इनर्शी के बारे में
No, it can be non-zero. Why? Because let's say it is half of the time in this direction, half of the time in this direction. Doesn't matter. Kinetic energy makes the square of momentum. So it is always positive. In fact, your average kinetic energy can't be 0. If it is 0, it means your means your energy is 0, and energy can't be 0. Minimum energy is pi square h cut square by 2 ma square. So your average kinetic energy can never be 0. It has to give you some positivity. Okay. So जल्दी बताओ, हाँ ना, फिर क्वेश्चन करें 2-3. बोलो बोलो बोलो, समझ लग गया? क्वेश्चन करें? चलो क्वेश्चन करें. हाँ बताओ. किसी लड़के ने कुछ बोला है, बताओ. Okay, so the task is you are given phi, which is equals to phi 1. Okay, it's a very simple question, and you are asked to find the average value of x square. This is your first assignment. So how do you find x square? phi1 star into x square into phi1. How, what is the value of the, oh sorry, phi1 into like this, and then how you write it, phi1 star into phi1 dx. So you need to tell me the answer of this in the group. Go home and solve this question. So number one question was this. Okay. Second question. Keep noting down the questions. Okay, very important. It is very important for practice. Second question. Let's say the phi is given to you. And the phi which is given to you is 1 by root 2 phi1, 1 by root 2 phi2. Now this question will have many parts. Number one part. Okay, so let's not do 1 by root 2, 1 by root 2. So the your is simply this. This is your simply state. Okay, simply this is the thing which you need. Okay, now the first question is normalize phi. Normalize phi. To normalize phi, you need to do phi into phi equals to 1. What is phi into phi? It is phi star into phi dx should be equals to 1. So this is a thing which you need to make sure. So whatever answer you get for this quantity, just divide the square root of that. So let's say this thing gives you answer 4. So you divide this entire thing by under root 4 so that it will be normalized. So you need to do this. Okay. Second part is find the average value of x for this state. Similarly, find the average value of p for this state, and similarly find the average value of x square for this state. If you do all these four things, trust me, you will get a good mathematical clarity. You will get the good physical means thing that what is happening here. So now coming to the portion, oh sorry, coming to your questions, that I think these two problems are enough to give you a good practice of one dimension well. So now it is up to you. You can ask the questions. Today's lecture is till here only. Let me stop there.